In this video, I am going to solve the problem 23rd from chapter 19. So here I am going to solve the part D, E and F. Figure shows a cycle undergone by 2 mole of an ideal monoatomic gas. The temperatures are T1 equal to 300 Kelvin and T2 equal to 600 Kelvin and T3 equal to 455 Kelvin. And here we are going to consider the state from 2 to 3, and for this state 2 to 3 we are going to find what is the heat energy transferred and what is the change in internal energy of the gas and what is the work done by the gas. So here you have to see the figure. We are going to solve the question for the state 2 to 3, and in the figure they clearly mention the state 2 to 3 is an adiabatic process. So what is an adiabatic process? In theory class we studied, if it is an adiabatic process, the heat energy is equal to 0, right? So if you write the first law of thermodynamics, what is the first law of thermodynamics? The first law of thermodynamics says Q equal to the change in internal energy plus work done. Now if you substitute Q equal to 0 here, this equation will become the change in internal energy, which is equal to the negative of work done, right? So this is the condition for adiabatic process. So now we are going to answer one by one. First question, we are going to find the answer for the heat energy. As I already mentioned, if it is an adiabatic process, what is the heat energy? The heat energy transferred, which is exactly equal to 0. So the answer for the D part, the heat energy transferred is 0 in adiabatic process, right? Okay. Now we have to answer for change in internal energy. So change in internal energy we are going to find. So what's the answer? We studied the change in internal energy, and here the condition they mentioned, it is an monoatomic gas, right? So monoatomic gas. And for this, the change in internal energy is given by the rule NCV delta T, where Cv for the monoatomic gas takes the value of 3 over 2 times R. And this time the temperature change is from T3 to T2, right? Because we consider the state 2 to 3. So final temperature minus initial temperature. So now what I'm going to do, I'm going to substitute the value of Cv here. By that, this equation will become N multiplied by 3 over 2 times R multiplied with T3 minus T2. Now I'm going to substitute the value, and the temperatures information is already given. T1 300, T2 600 and T3 455. So better I can write the temperature here. So T1, which is equal to 300 Kelvin, and T2 takes the value of 600 Kelvin, and T3 is equal to 455 Kelvin, right? So I'm going to substitute the value now. So what is the number of moles? The number of moles they mentioned, it's 2 mole, right? So let's substitute the value here. So 2 multiply 3 over 2 multiply with the gas constant 8.314 multiply with T3 minus T2. What is T3 here? 455 minus 600, right? Okay. Now I am going to calculate the answer for the change in internal energy. The answer I got for this part is minus 3.614 multiply 10 power 3 joules. So this is the answer for the E part. Clear? Understood? Okay. Now we have to go for the F part, because in this question we are going to solve only 3 subdivisions, D, E and F. And for getting the answer for F part, it's very easy. We already found the answer, right? How? I'm going to explain one more time. So for the F part, we are going to find the answer for work done, right? As I already mentioned, if you substitute the value of Q equal to 0 in the first law of thermodynamics, so first law of thermodynamics, Q, which is equal to change in internal energy plus work done, right? And here it is a process, adiabatic process. So Q equal to 0. When you substitute Q equal to 0, what will come? Your work done is equal to negative of change in internal energy, right? As we already found the answer for change in internal energy in the previous part, so I am going to take the answer and substitute here. So what will happen? The answer for the F part will be very easy. So once you substitute the answer from the previous part, what will happen to the work done? Work done, which is equal to negative, because we have the negative here, multiply with this value. Already this value have the negative, so minus 3.614 multiply 10 power 3 joules. So minus multiply, that means the minus into minus become positive value. Therefore, here the work done is a positive. We'll take the value of 3.614 multiply 10 power 3 joules. So this is the answer for the F part. Clear? That's it. Thank you.